Okay, good morning, everybody. My name is Timos Sellis, and I'm coming from the Archimedes, let's call it Research Center, but I don't want to confuse it with the research center that hosts us. It's Research Center Athena. So let's call Archimedes a research unit. A few words about me. First of all, I'm not an AI person, I'm a big data person. Let's make this clear. So I don't want to claim anything that has to do with AI in terms of my background. Although I introduced and taught the first AI course in my university, the National Technical University of Athens, for about 15 years. But that's a different story. Okay. So my background is data management and databases, for those of you familiar with the terms. And for many years, I was in academia. So I was a professor in the US, then a professor in Greece for 20 years, then in Australia for 7 years. Then spent some time at Facebook as a visiting scientist, and back to Greece, where I have the role of the scientific director of Archimedes. And a few words about Archimedes, allow me some advertisement. Archimedes is a new research center, which is a research unit, which is focusing on AI in general, but the priority for us is basic research. So Archimedes is offering an environment in Greece. By the way, it's not bound to Research Center Athena. I call it a Greek graduate school on AI, data science, and algorithms. That's the full title of the center. And our goal is to offer mainly to doctoral students the ability to study in Greece instead of going abroad, but having in their supervision teams also Greeks from abroad. Okay, so you met Christos Papadimitriou the first day. He's one of our not only researchers, he's what we call a principal scientist, with Konstantinos Daskalakis, who's a professor at MIT, and I think will give a talk the last day. We have 31, as we call it, collaborating researchers. They come from universities in Greece, research center in Greece, universities from the UK. You met Sotos Tsaftaris on the second day, Maria Bakalopoulou as well, and Evi Pitoura, who's from Ioannina. So we have researchers collaborating with us. They're not our employees. And then these researchers are basically supervising doctoral students. This week, we're putting out, some of you may be interested, a call for postdocs. We're going to have 10 postdoctoral positions, 2 years each, to spend time in Archimedes and work with us. And then we're going to have internships for students at all levels, undergraduate, graduate, doctoral, etc. Okay, so all in all, Archimedes is doing two things. One, offering a nice environment, we hope, to do research in AI, data science, and algorithms in Greece. Of course, it's open to foreign researchers, people coming from abroad as well. So we're going to, this summer, starting next week, we have like 10 people coming from the US students, doctoral students, and Cleopatra and Konstantinos that were with us last summer, actually in the premises of IVA, met a lot of our researchers last year, and also students that came from abroad. So I'm sorry for this long kind of introduction, but I wanted to set the context. Now, as I said, I'm not an AI person. Let's say I'm a big data person, but today I don't want to talk about that much about technology. And the reason I chose this topic is because, and I'm sorry, I have to make sure. The reason I chose this topic is because I would like to say what my view is about the connection of work that we do in data science, or big data, if you want, with respect to what's happening in the society, which includes AI. Now, uh, I, I think I don't need to make this introduction, but I'll go very fast over it. You all know that data science, um, let's say it's a new area that emerged a few years ago, and it sits at the intersection of computer science, math and statistics, and what we say domain and business knowledge. Okay, so the idea behind data science is not to just claim that working on data is science by itself. That's another story. But it's also important to indicate that at some point data became so important, as we will say in a few minutes, and we felt that we need to concentrate and study what are the consequences of working on data and what kind of changes we need to make in research on data. And when we zoom in to data science, um, you know that there are probably a lot of these areas that you have heard about, from modeling and statistics, let's say, to technologies, and then to scientific methods, data consulting, etc. That means that it's not a technical area only, data science, okay? It reaches out to other areas, and we have to take this under account. And if you zoom in even more, this is just a word cloud, as they call it, on the frequency of terms associated with data science. And you can see this is what I call MS. Of course, you can recognize with big letters machine learning, that we all know. It's almost synonymous to AI these days. When people, everybody that I know that talks about AI basically talks about machine learning. Just to make clear that it's not that we talk about all the areas in AI, but data mining is coming from our area, and this is, if you want, the predecessor of data science, data mining. But you understand, if you go around these words, you will see that most of them are used when people talk about data science. And of course, when you talk about data science, you need to also have an idea of what kind of pipelines we have in our mind. And what we mean by pipelines in our field is what kind of processes. Like, for example, if you think of any problem, it starts with what's happening in the real world. Then we collect raw data. The data is processed because, as you know, raw data can be dirty, can be uncertain, can be, we can have missing data, etc. So, oops, I'm sorry. So we have a clean data set here, and then this data set goes into what we call exploratory data analysis. Now, why do I use the word exploratory? What do you think? Just in plain English. Why do we say exploratory data analysis and not just data analysis? Yep.
Give a first quick look at the data.
Yes, because in real world, you collect data, you don't necessarily know the complete semantics of the data. It's like many of us, when we collect data, we have a questionnaire, and then we know what each answer corresponds to. But when you collect data from the real world, and this includes text, so you take an interview from somebody, right? Now, what we mean with exploratory is that in the beginning, we go into the data and try to understand what do we have here. This is called data exploration. It's a field that emerged in the last 15 years when people realized, yes, we know about databases. You know, many of you may have used databases, but many of you may have built databases. And you know that to build a database, you need to come up with tables, and you have to put column names, and you have to say, oh, this is a string, this is a number, this is etc., right? This is rigid data. So we know exactly what it is. With data exploration, the first thing that people do is they go around and, first of all, they say, do we have data about this? Do we have data about ages of people? Do we have, so it's what we call the difference between finding and searching. You go and find something, or you go and search. You search when you know what's there. Find is first I need to find what's there, then I can search it. So we do exploratory data analysis, and then out of this, we build models. So we know now that the data that we have conform to these models, for example. Okay, and then if I know the models, then I can certainly write algorithms to do analysis on the data that I have. What happens next? Then we build, as we say, data products. So a data product is the Google search engine, because behind the Google search engine there is something like what we call an index. So when you put a word in, it points you to the right places. Yeah. So this is the data product. Another data product is any website that you use for tickets to make a reservation, right? This is a data product. And then, of course, we don't forget that you need to be able to communicate and to visualize the data. That's by itself a very, very interesting area. So what you see in this data science process is my simplified version of what's happening when we talk about data science. It's not just data. We work on data. No, you have to work on all these areas if you want to talk about data science. And you have to make progress, and you have to build tools, etc. Now, moving to society. You know that this term, Industry 4.0, is, which is mostly a European term, but when I was down in Australia, it's heavily an Australian term as well. And Industry 4.0 is trying to basically capture what we call the fourth paradigm of or industrial revolution. So I don't want to go into this because I understand most of you know about it. But there are people also talking about Society X.0 in the sense that they say the first, let's say, instance of our society was centered around what we call the hunting society, like I want to live, I want to find food, and that's basically it. Then we coexist with the nature, of course, the agrarian society, Then we start using tools, and then we have this industrial society. Then we move to using information, so we get into more like Industry 3.0, let's call it that way. And then what's happening now is that you have the coexistence of people, machines, and of course, let's say, computerized versions of people, like robots. Okay, so this notion of Society 5.0, as they call it, so if you count it, it's the fifth generation. Or some people call it the super smart society, doesn't matter. These terms, I mean, depending on who you talk to, this is by the way, coming from Japan, who were the first to introduce Society 5.0 and make it the center of their activities. Okay, so apart from Industry 4.0, let's say, Japan was the first country to say, yes, but we have to look at what's happening to society. So, what is Society 5.0? What are the characteristics of Society 5.0? It's a human-centered society, of course. I mean, many people, including myself, don't care about a robot-based society. Okay, we are a human-centered society. Period. Now, it's a hybrid space society because you merge cyberspace with physical space. That is for sure. I mean, you all do it every day. The industry does it every day. Maybe you have heard, of course, the terms digital twins, where people say, okay, if we're going to work together with a robot, let's build a digital twin so we can simulate, for example, how a robot works. Yes, you can do that, but still you cannot simulate how a human works or thinks. Okay, we'll come back to that. Then, of course, it's a technology-based society. We understand that, and there is no reason to say it's not. It's a knowledge-intensive society, absolutely. Okay, and we understand as well that people are basing a lot of activities on knowledge. And I think it's important to know that's a data-driven society. Now, somebody may say, someone may say, what's the difference between knowledge-intensive and data-driven? You understand the difference? What would you say it's a data-driven society, if you agree, of course? If you think most of our activities today, they're based on data. Am I right? No? I mean, data is what you see. Data is what you hear. I mean, all this is data, which of course we have to convert to information and make it more useful, but we all understand that our society is data-driven. And if it's a data-driven society, you have to take care of where this data is coming from, how you collect this data, etc. Now, my simplified model of society, and this is how I just wanted to have a general way to look at this issue, is that basically society is people and institutions. And by institutions, you may also think of machines that simulate institutions, or real institutions that have people that work in these institutions. And then you have regular people, the blue circles. And what happens, in my opinion, these two actors work together using data. So you talk to an agency, or you send an email to an agency, or whatever you do, it's basically exchanging some data with an institution, or people among ourselves, we exchange data, institutions themselves, they exchange data. And this could be natural language, voice, images, numbers, and has always been that way. Okay. Now, why I'm saying that? Because what I want to talk about is, given this, what do we know to do well up to now? So anything that has to do with institutions, and again, under the prism of information society, data, I think we do a lot of things well. Like, for example, we can collect data almost from anywhere. Can you think of any data you cannot collect nowadays? I mean, you can put electrodes in here and collect brain signals. You can put sensors on anything and collect. So the only things you cannot collect, which is not data, it's like fantasy or ideas, right? Again, still you can collect that because many people write about their fantasies. They write about ideas. So if you think about it, and we have a lot of technology to collect data. Then we have a lot of technology to clean and integrate data. So you give me a data set of addresses, I can easily correct addresses nowadays. Okay? You give me a data set of names, even for names I can correct. Okay? Now, this is not always easy because, especially integration, if you put two data sets together, and many of you have done probably that in your lives, it's very difficult sometimes to put them together because some people called me Timo, some people called me Timoleon, and then how should I know it's the same person? Just an example. Then we can store as much data as we want, and we can transmit it as fast as we can, right? That goes without saying. We can analyze data in a smart way. Machine learning, deep learning, supervised, unsupervised, you have heard these terms. We have a lot of expertise and a lot of technology developed to analyze data. We can do it fast because we have fast machines. We can do it at scale because we have big machines. You can store a lot of data, you can handle a lot of data. And of course, we have ways to visualize data in a nice and digestible way. Now, this is something that we're still working on because depending on the applications, it's not straightforward how you visualize data to make it useful to a human, but we can. Now, the problem is what we don't do that well. We do reasonably well on how we collect data respecting privacy. I'm just picking one property about collection, data collection, which is respecting privacy. Okay? Now, we do reasonably well. We don't have a solution for everything right now. We can secure data to avoid leakages. Again, we do it reasonably well. But still, there are adversarials that will try to grab your data. We can offer the right to forget data. You see, I'm putting some things here that, although we as humans understand it and it's clear, if you go to people that work on machine learning and you say, can you forget data? For example, with machine learning, you can build a model that based on trillions of cat pictures, I can recognize a cat. All of us have heard about this, right? Okay. Now, when I go to the model and say, forget about these pictures, that means these pictures were wrong. Delete them. How easily can I redo the model so that these pictures are not taken under account? If you ask people working in machine learning, this is a huge problem. And for us humans, forgetting is, first of all, it's a right. I mean, I can ask any organization to forget my data. Anything I produced, I can ask you to forget it. Unless I have signed these small letter things that say you are never allowed to delete your data. We can increase trust to institutions. We can attack bias and increase transparency, what Evie Pitura talked about, right? But still we can do better. That is the reason all these areas, in my opinion, are still hot research areas. But we need to put more focus, in my opinion, to address the needs of humans being part of a society. I've never heard of anybody, and I'm sorry, but in many interviews I give, whenever I talk, I always put the question, yes, it's fine what we do with AI, etc., but what is the real problem that came from society? I can understand the problems coming from technology and from the wish all of us have to explore more and smarter and whatever things. But is that what we need? So what I'm saying here is, suppose I want to address the needs of humans being part of a society. So a human-centric view, which everybody talks about. Everybody says this is human-centric, human in the loop. You know, we do this for people. And then you say, okay, autonomous cars. You do that for people, right? It's clear. No, it's not in my mind. I understand you do it for the environment, you do it for less accidents, etc., etc. Yes, but point to me a person that came and said, I wish I had an autonomous car. Because you can use buses, you can use trains, you can use other means to decrease accidents, to decrease traffic, to decrease emissions, etc. Focus on solutions taking under account the human's needs rather than the institution ones. So that's the point I'm making. I think most of the things we are looking at are based on institution needs, and that's fine. Okay? Institutions to work properly for the society, they need changes, they need technology, they need new ideas. That I can understand, but also what happens with the human. So at that point, when I thought about this, I say, okay, let's start from the roots. And I am not a sociologist. So the only thing I quickly went over the internet to see, how do we specify what the society needs? And I came across this, which I liked. It's simple. And I said, okay, uh, I didn't know Maslow's hierarchy. I've heard about it from my wife when she was doing her PhD, but I never spent time to think about it. But then when I looked at it, I say, okay, if this is an expression of what the society needs, um, how can I go and look at the relationship between this pyramid and what we do nowadays, or what we need to do to contribute to this pyramid, which my interpretation is, for example, uh, when you talk about physiological needs. And what I'm doing in this slide, there's only one slide per level of this hierarchy. What I'm trying to do, and this is something we can discuss and we can think together, is um, if, if data science is going to contribute to society 4.0, 5.0, whatever, society X.0, let's look at the pyramid. So physiological needs. What I put here is basically what I collected from Wikipedia, etc. So it's not of course mine. And some people may say it's wrong that you started with Maslow's pyramid. There are other ways to talk about human needs, etc. It doesn't matter. I want to say that somehow I would love to see people concentrating, for example, physiological needs are considered to be the first step in internal motivation of people. I mean, I need food, I need shelter, I need to cover, you know, it's human survival. So homeostasis, food, water, sleep, shelter, basic stuff. Now, of course, you will tell me, okay, so what? How data science can help to that? And I'm trying to make some observations. So, for example, in the past decade, social data has increased so much. It's, as I say, beyond our imagination. And people really leave their digital traces every time, every day, anywhere. I mean, we talk about privacy in health data. I go in Facebook, or I'm not a lover of all these social networks, but you go into one of these social networks and people talk about their physical stuff. They talk about their health. So one company, I like the idea, one company in Australia say, you want to do random trials, clinical trials, go to Facebook, and it's not that you identify people, but you can target putting an advertisement there instead of what I remember seeing in the toilets where they say, we're looking for male smokers aged between such and such. You cut a piece of paper, the number you call, and you volunteer. This is much more difficult than going and analyzing so much digital traces, as I say, that people leave around. And then, of course, if you start thinking about loyalty cards, Google, social networks. So you don't leave your traces only on social networks. You leave your traces, right? You go and shop to the supermarket with a loyalty card, and of course you leave a trace of what you eat. So is there a prospect for a new kind of social research? For example, how can data science work? You can have what I call high complexity analysis of very high volume of transactions, very high volume of interactions, etc., highly linked data across various areas. And then you can have dynamic real-time models, movement. Of course, we all use Google Maps or something like this, and the movement of people is a very important digital trace of what we do. I mean, you know about that. Okay, so pretty much there is somebody in the world that knows when you leave your home, when you are in your office, I mean, I don't want to continue. So I'm not saying that people are using that for a bad reason, but I'm saying that if we are to help around the first level or the physiological level of the pyramid, we have to think, what should we develop to help people? So, of course, you will tell me how that help somebody in Africa to find food or water or shelter. Okay? All I'm saying is for these needs of people, we can use data to improve what information everybody has. Similarly, for safety, that's the second level. So, safety, according to the definitions I've seen, could be physical safety, which can cause, of course, trauma. Economic safety, that's something that comes up very often, everywhere. So due to economic crisis and lack of work opportunities, you have these issues with economic safety of people. And of course, when you think about economic safety, you think about jobs, you think about protection of people from other authorities, you think about insurance policies, disability accommodations, etc. So there are a lot of issues connected to how safe people feel. So safety and security has a lot of dimensions. And again, if you think about it, a lot of Internet of Things applications are covering, in my opinion, physical safety. So now there are homes for elderly people that are fully equipped with sensors. And yes, you can know if a person moves from the bedroom and goes to the toilet, if the person disappears somehow and may have fallen, etc., etc. But the problem is you need to do that under privacy and trust rules. Okay, so it's not science fiction. It's not the red buttons that you give to elderly people to push. It's all I'm saying is that we do have the technology to have a way to make living at home safe and secure to some extent. Okay? And of course, we all know that living at home carries financial implications, not only social implications, but mostly social. Who wants to live in a residential house in Greece? Let me make it more specific. Very few residential houses are taking care of the elderly. Okay? Yes, it's better. My father and my mother, they're 91. They don't even want a third person in the house to help them. Okay? Thank God they accepted that just a week ago. But no, it's very common. And you know, I want to take this under consideration. I don't like to go and impose a solution on them that says, this is the person you're going to have here. No. They pick the person slowly. You have to be, as you know, patient with that. And then, of course, data plays important role in areas for financial security. So anything that has to do with medtech, digital health, etc., is very important in this area. Now, moving on, social belonging. Okay. According to Maslow, humans need to feel that they belong and they accepted in social groups. I mean, we may disagree, but if you think about it, yes, we want to feel that we belong, we are part of a society. It's not us alone. So some large social groups, for example, which includes clubs, co-workers, religious groups, professional organizations, sports teams, etc. You can imagine all these are large social organizations or social collections, and smaller ones are just a family, just intimate partners or mentors or colleagues, etc. Now, this need of belonging may overcome, as we say, the physiological and security needs, depending on the strength of the peer pressure. And this is something that people experience, okay? And social belonging is anything that I mean, a friendship, even on a social network, a friendship is because I want to belong to a social group, okay? So you can translate, what I'm saying, you can translate these concepts to things that are happening in the digital world as well. Now, data science has advanced a lot the work around social networks. I'm not saying that social networks is, I'm sorry, the social electronic networks that we're using is the right implementation of social belonging, but we should not forget that data science has made the work on social networks uh, available so that you can do large-scale analysis and management. What do I mean by that? If you want to look for people that share hobbies with you or that have shared interests, etc., there is a way to search in the social networks. And the way we were doing it as people is, is quite similar because I would ask a friend, do you know a club for bridge, for example? I want to join a club or whatever. I mean, you would do it by asking friends. And that's what you do on social networks, except you're doing it not by voice, but you're doing it in an electronic way. And a lot of work around community detection, influence maximization, privacy and trust, etc., has been done. What do I mean by community detection? What I just described. Can you find me all the communities that have an interest in bridge, that have an interest in communism, they have an interest on anything? You can do that on social network data. And then, of course, you can do, as we say, things like, some people like to influence others. I'm not talking about, I don't know, I don't even understand this term influencers that they use in social networks, but I'm not talking about that. I'm talking about, I want to post something that I feel is important and can influence people. How can I reach the right people for that with that post? Does that make sense? You do it in a newspaper, you don't know who reads it. You do, but on the social network, I'm not saying that you can find these happening in things like Facebook or Twitter or whatever, but I'm saying that, and I'm pretty sure, you can pay one of these companies so that what you are putting in there can reach the right people. Why am I saying that? Because, I don't know, again, I get on the social networks like Facebook just to see what's happening. I'm not interested in posting anything. I'm not, except when my kids were young, I wanted to see what they were doing on their photographs. That's fine. But all I'm saying is that I see all of a sudden, and I get things like, this is suggested for you. You know? This is recommendation, like Netflix. I'm not saying that this is influence maximization, but somebody has probably set some parameters to indicate that, this should reach these kind of people, whatever. I hope I'm not in trouble. So social belonging is, I'm sorry. And then esteem. When you reach at that level, and if you remember, we are at the fourth level, the top one is self-actualization, and probably I should go faster. Esteem is seeking respect, right? So esteem needs, in my opinion, but I'm not claiming that this is my sentence, are ego needs and status needs. Yeah, I think we all feel that. People develop a concern with getting recognition, status, importance, respect from others, etc., etc. That's esteem, right? So the lower version of esteem is the need to for respect from others. The higher is basically self-respect, and we all know that this is two different things. Now, how can data science contribute to that? We have advanced the work a lot. We have advanced not only the technology, but also the means, as I say, for finding, searching, and identifying information about the perception people have of other people. So you can go in a social network and use a way to find out what people feel about you. Even simple things like sentiment analysis, how people talk about me in a positive way and a negative way. But this can go even further, right? So this is what I mean by that. You can go you can find, you can search, and you can see the difference. I mentioned that earlier, and identify the information that I need to, and it has to be evidence-based, right? Because many people say, "Oh, we respect you, and you're a good teacher," and many of my students say, "Oh, I remember in the university, you were one of our favorite professors." Yes, but this is like part of the evidence. Somebody says something about you. And sentiment analysis, citation analysis, for example, look at publications. Esteem is basically citations, or respect, if you want. Of course, you will tell me some citations are negative. And maybe they say this paper is an awful paper because they did this wrong. But still, somebody read your work and they have an opinion, positive or negative. Okay. So these are some of the things, by the way, that we can do very, very well. Okay? And a lot of work around fake news, entity identification, entity linkage, etc., are things that data science has contributed. Okay? Fake news is not AI. Okay? I want all of us to understand that. Under AI, we just put everything. No, fake news identification is data science. You get data, you get the news, you analyze them. And why, how do you prove they're fake? What do you think? How do you prove they're fake? I mean, some people may use counterfactuals. So you say that, but this is what was published in the official journal of whatever, the European Commission. And you say something different that was referring to that. So all I'm trying to say is that some people have written algorithms to take the data, analyze it, link it. Entity linkage that I mentioned here for some of you, entity linkage that I mentioned here, that for some of you may not be familiar with the term, and entity identification are the most important things we do in the beginning. So give me a piece of text. What are the main entities in the text? I mean, for us to recognize a person's name is very easy. How can a machine recognize that Timoleon is a person name and not a mountain, which could be the case? So all I'm saying, to do this entity identification, you also have to take care of entity linkage because there are entities in different places that refer to the same concept. So anyway, I think you get the idea. And then self-actualization, I don't want to go into a lot of detail, but what a person's full potential is and the realization of this potential is self-actualization, according to Maslow. Okay? That's the desire to accomplish, as we say, anything that one can to become the most that one can be. Okay. So just take this sentence and then take some time, and depending on your field, you can write down, so how can I contribute to that? This is what I try to do with data science. So what went to my mind when I first read this is personalization. So, you know, I want you to see me as a unit, not as one of 11 million people living in Greece. And to do that, I want you to spend time to understand what my needs are, okay, what my potential is, etc., etc., and use personalization on this, a lot of data that you have, in order to analyze the data and give me some personalized recommendation. Now, again, we all hear about that. You get personalized recommendations on Netflix, you get personalized recommendations on social networks, you get, yes, but all I'm saying is, yes, but if we need to focus on this, what I have up here, it's not my full potential to watch the movies that you think are relevant for me. Okay? You have to understand what my full potential is as a person, with what properties I have, etc. And analytics, This is something that I want to mention because many of us talk about analytics. Analytics can be, as I say, descriptive. And descriptive analytics means let's analyze the past. Let's get some statistical data or evidence about the past. Predictive means let's use the past to predict the future. In my opinion, the most important is prescriptive. And this is something we don't know very well to do yet. But there are some works that have started in the last few years. What's prescriptive? Prescriptive means you predict that this person is going to get an 8 out of 10 in my course. Okay? Okay. What do I need to prescribe to this person to get a 10 out of 10? Does that make sense? A doctor. You predict this patient is going to end up having diabetes, etc. What do you prescribe for this not to happen? So instead of reaching a value of X, to reach a value of Y. That's prescriptive analytics. So if you think about it, it's like what we call what-if analysis, yeah? Yeah, but believe me, if I give you 1 billion data that you analyze and you get a statistical number, like an average, or, I mean, average is simple, but anyway, more complex computation, and you reach a value of 10, and you want to make this 15, this is what we do when we work with industry. Say, a production line may be productive, and you may get whatever KPIs they use, a KPI of 75%. Another characteristic in industry is preventive maintenance. So you predict this machine is going to break down in 1 month. Okay, what do you do? What do you do in order not to break down? It's not a matter of analyzing the physical performance of the machine, because what we are suggesting, let's make this a data-driven decision. So collect all the data. I mean, that's a very strong statement. What does it mean, all? Collect all the data you can imagine of, and then use the past to see. With this data, I ended up having a problem with this machine at day 5. With this data, now, can you use this to predict more accurately? And moreover, can you use this to make sure that something does not happen that will lead to that? Now, that's difficult, but believe me, it's not improbable. So you can do it. It's not undoable. Okay? In some areas, you can do it. So just to give you, this was my view of what we can think of when we talk about data science related to society. I'm just putting here Japan Society 5.0, some of the goals that they have, just as a comparison. So that you see, if you haven't looked at this area, and I believe, coming back to the title of my talk, with socially responsible innovation, I think when you talk about Society 5.0 and what innovations we need for society, it's good to understand where you start from and what you want to do. So they say, flying machines will come to your town, drone delivery. Okay. Smart home appliances will make daily life more pleasant, AI refrigerator, AI speaker. Okay. Tireless helpers, and they have, by the way, this is done, right? Nursing robots is there. It's not they want to build them. They have nursing robots that lift people. They have robots that help elderly people. They talk to them, etc., etc. So giving assistance to caregivers and care recipients. Excuse me. The increasing role of robots will banish hard labor. Autonomous tractors, cleaning robots. Yes, that part we all know. And, you know, for some of the work that we do, the humans, it's good to have machines to do it so that we don't have problems. Make shopping and traveling more convenient with a giant cloud. So accounting, shopping, everything is going to be electronic. Everything is going to be on the cloud. And a new hero is emerging on the scene in logistics and transportation, autonomous buses, truck caravans, etc. So this is the official Japan's Society 5.0 goals. By the way, Japan was the only country that I know of that ever developed a strategy for AI in the past. You, you've seen these curves with AI hikes and winters, right? So in the 80s, and that's the only country that I know of that had a goal that the goal of the government was to make AI strong. It was only Japan that did that, and that was in the 80s. So if you look at the United States, if you look at the UK, other countries, nobody had a goal as a society, as a country, that we will be the first in this area. And Japan was the only one. And some good things came out of it. And as I say to, and when I joke about it is, uh, unfortunately, the only thing we have experienced out of Japan's AI boom and a lot of money is what we call fuzzy logic in air conditioners, dishwashers, washers, etc. This notion of fuzzy logic, some of you may have heard it. That's the only, well, I'm exaggerating, but it's the only commercial outcome that many people. So, in my opinion, what's next for data science? I think we should make efforts to build, as I say, programs, data science for social good. We want ideas by people on how to use data science really for the social good. And by the way, there are some programs like this. If you put this in Google right now, or in any search engine, I'm sorry, if you put this in any search engine, you will find links to programs, mostly from universities, that are called data science for social good. I ran one of these programs in Australia, the university I was at, with support from Amazon Web Services. You may have heard it. It's a big cloud provider, not only. And the way we modeled this is we had an organization, for example, the Ministry of, which I don't remember what, from the state of Victoria in Australia, came to us. They wanted to do work on family violence. They wanted to understand what's happening with family violence, etc. So they worked with us to analyze social network data, to analyze other kind of data that they gave us, etc., in order to get a better glimpse on what's happening with family violence, what characteristics we have, etc. So these are the things that the social good comes from organizations that look at the society and they have specific problems they want to address. And then we help them. And the way we did that, by the way, is by building teams of undergraduate students, supervised by graduate students, together with the organization that had the problem. They worked all together to develop a solution in 8 to 10 weeks. So it was not a general thing. You had to deliver something that's useful to the people that need it. And of course, if you again search on the internet, Microsoft has something they call AI for good, AI for humanitarian action, AI for accessibility, AI for Earth are the three pillars they have, but there are other organizations. And of course, half of them are using AI for good as a slogan, as a way of what do you call it, social responsibility for the companies. But some of them, I think, there are some good efforts that really believe in this. And in terms of data science, this is my final slide, I think. Yes. So I think we should focus on Maslow's pyramid or something like this to better understand and connect the work that we do in AI, data science, etc., with what people need, to develop methodologies and tools that drive people upwards this pyramid. And of course, without overlooking the fact, as I say, that we need to digitally disrupt what we're doing now So that's better across institutions and people. I think digital disruption, as we all know, is a big discussion. Um, um, thank God, many people stopped thinking that you can disrupt digitally by just putting a machine on an employee's desk and asking the employee to work in a digital world rather than on papers that they used to work. Um, Digital disruption is much more complicated, and there are many people focusing on how to make this successful. But uh, what I mean by disconnecting that we should focus on Maslow's pyramid and to uh, to do digital disruption in a good way is because I feel that you need both. You could call it digital literacy that you need to improve. You can call it digital disruption. You can call it digital transformation, but that's different. The first one says, let's focus on something that looks at what the needs are, and then we can decide what to do next. And I think with this slide, I'll stop here. Thank you.